The topics can originate from teachers, from curricula, from standards, from students, from the community, etc. So it could be like current events that are going on related to computer science. It could be a professional topic that people in the field are discussing, or that is relevant to the community that you work in, or even to individual students that you work with. So both teachers and students can draw inspiration from like academic works, from newspapers, from blogs, from TikTok, from wherever. And again, going back to the ideas that are discussed in the Rhizomatic podcast episodes that I mentioned, you don't necessarily have to come up with just one topic. I would recommend starting with just one topic if you are new to project-based learning, and then eventually you can get to like choose from these 3 options, and then eventually, hey students, there's 30 of you in this class, let's come up with 30 unique projects that are interesting to each one of you, and then you as the teacher will facilitate 30 projects simultaneously. That's on the far end of the progressive continuum that might take some practice, and that's something that I did in my class. So students had several programming languages they could choose from, and they could work on any project that was of interest to them for any length of time. Could be for a couple of days, or could literally be for a couple of years on one single project, up to the students. You don't have to start there. You can just start with what's outlined in this article, which is how to create a single project. So the authors mentioned that whatever topic you pick, it should spark some wonderment. It should encourage them to imagine and think about like computer science in new and different ways. It should have long-lasting value, and it should also meet the curriculum requirements if you have to worry about that. And on page 42, the authors mentioned something from a book that I read a while back. So here's a quote from that. So it's talking about how student experiences should, quote, be assessed as to their generativity, the extent to which experiences generate additional experiences by creating a need to know. Vibrancy, the extent to which experiences are both minds-on and hands-on. And residue, the extent to which experiences provide a positive and affirming sense of achievement, end quote. So generativity, generating some kind of a need to know. So this is talked about a lot in scholarship on like video games, and how video games create a need to know, in that in order to progress through an area, through a level, or whatever, you have to learn a specific skill. And so if we take that idea and relate it to education and like computer science education, creating some kind of a topic or coming up with some kind of a topic that makes it so that students need to know a particular thing in order to be able to progress in that project. For example, if you want students to be able to create a game, they're going to need to know player controls. You don't necessarily have to outline that at the beginning, but if it's going to be some kind of an interactive game, then students are in some way going to think about interactivity through some kind of a player control, whether it's point and click or keyboard or mouse or whatever. When it comes to vibrancy, students need to be able to engage in both the minds-on and the hands-on. So it has to have those two paired together. There is a tendency when we're talking about like theoretical applications of computer science or whatever, or maybe even some of the ethical implications of computer science, it's a lot of talking and not necessarily a lot of doing. So we might talk about some of the problems with algorithmic bias, but we're not necessarily trying to rewrite algorithms to fix that bias. Depending on the age group and the topic, you might not have that opportunity to actually have students write their own like deep learning AI system or something like that. That's probably not going to happen, but maybe. And that's not necessarily a bad thing. You don't have to actually like create something from scratch or remix something, etc., in order to have it be hands-on. One of the things you could do, if we go with like the topic of algorithmic bias, is have students try and break it to figure out where is this algorithm working as it is designed, and where are the biases coming out of this. So if we look at like facial recognition and whatnot, you could like give different data from different faces, and then try and find, okay, where does it actually recognize the correct person? So give a correctly identified face that it recognizes, and where is it actually like not working. So as a lot of scholars talk about, facial recognition technology does not necessarily work well with darker complexion, because the data that was provided was with people who had lighter complexion. So it was run off of data set that was a certain type of face or certain color or darkness of the skin. So it doesn't necessarily work well for the skin types that were not used in the original data set. That is a way of engaging in hands-on while also doing the minds-on with like ethical discussions around computer science education. And then with the residue, when students walk away from this, are they going to walk away feeling like they accomplished something? Do they better understand some of the ethical impacts of algorithmic bias and better understand how to address it and to look out for it and go, oh, this is working really well in this context, but it has a clear bias against this other context. That kind of residue can have this like long-lasting impact that ideally we want to have in class. We don't just want something to go in one year and out the other year. I'm thinking of my like social studies curricula in particular when I was a student. Memorize all these dates and facts and names of historical people, and then completely forgot about why they went into battle to begin with, and have certainly forgotten all the names and dates and facts, etc. Because those experiences in social studies did not have that residue. This excerpt of the CSK CSK8 podcast is from episode number 194, which is titled Bringing Curriculum to Life, Enacting Project-Based Learning in Computer Science Programs. You can listen to the full episode as well as hundreds more by searching for the CSK8 podcast or by simply going to jaredoleary.com.